Hey Math 85, this is section 10.6, finding the greatest common factor. And in the last section we did section 2.5, and we found the prime factors of a number and we used the factor tree. And so I'm going to review a little bit of that before I go to 10.6 because you're going to need those factor trees to do 10.6. So when we are finding the prime factors, and we're, breaking a number down into prime factors by using a tree, the big math word for that is, we call this finding the prime factorization. Of a number. So if I want to find the prime factorization and again this is probably just review from section 2.5, which you just saw that video, but I just want to make sure we have this and this is understood. So I want to find the prime factorization of 80. So in other words, I want to break down 80 into all prime factors. Okay, so break 80 down into all prime factors. And remember what a prime number is. Prime numbers only have two factors, one in itself, like 2, 3, 5, 7, 17, the list goes on and on. So I want to break this 80 down in just to all its prime factors. So what I want to do is I'm going to put 80 is at the top of my tree, and I'm going to make like branches, so I'm going to branch off, and I need two numbers that when you multiply them will get you to 80. Now here's a trick. Since it ends in 0, I know that 10 can go in, because also 10 and 80 both end in 0. 80 ends in 0, 10's going to go in. So 10 times what is 80? Well, 10 times 8 is 80. Now you don't have to use 10 times 8. If you have two other factors you want to use, like if you want to use 2 times 40 or 20 times 4, I mean, there's a bunch of factors you could use. But remember, you cannot use 1 and 80. You cannot use 1. So use whichever two you want. We're all going to get the same answer in the end. So then I look at the bottom of my branches at the 10 and 8. Are either of those prime? No. So I keep going. I'm going to branch off again. More branches. So I need two numbers or two factors. When I multiply them will get me to 10. and I can only think of 5 times 2. Okay? And are 5 or 2 prime? Well, they are, so I'm going to circle them, because that's going to help me at the end. So I'm looking at this branch with the 8. What two numbers, when you multiply them, will get you to 8? And let's see, I know I can't use 1 times 8, but I can use 4 times 2. Are either of those prime? Is the 4 or the 2 prime? Well, the 2's prime, but 4 can still keep going. So one more branch off the 4, and what are two numbers? There's only 2 that when I multiply them together will get me to 4, and that's 2 times 2. And I can't branch off any further, so I'm done, and both 2 and 2 are prime, so I'm going to circle. So I know I'm done when I have all my circles. I can't branch off any further. So then at the end I just want to bring my 80 down, and I want to write down all the numbers that are in the circles. So 80, here's all my prime factors. 5 times 2 times 2 times 2 times 2. So here is my answer. The prime factorization of 80 is 5 times 2 times 2 times 2 times 2. And if you want to check it, just punch this in your calculator and you should get back to 80. Or you could do it by longhand. 5 times 2 is 10, times 2 is 20, times 2 is 40, times 2, 40 times 2 is 80, so I know I'm right. Okay, so that's just a review of what we did in 2.5, and I want to make sure we got that, because we're going to be using these factor trees to find the GCF. So in the next video I'm going to do 3 examples. So the next video we'll pick up with finding the GCF, which is just greatest common factor, for 24 and 36.